Hello all. So is in this video we are going to learn a little bit about like single leader and multi-leader replication. Is this video a repeat of data from the intro intro of the replication video? Yes, a little bit, but I need this video for giving context for the upcoming videos. Okay, so bear with me. So first we start with single leader replication. So in single leader replication, what happens is that the client makes request to a leader. So this is leader, and then the leader replicates the data to the secondaries. Okay. So this is like secondary one, secondary two. These are being replicated. What are the benefits of single leader replication? So obviously the first benefit is there are many copies of the data. So the durability actually increases. So even if like something happens to this database, like Iran throws a missile to this database, this too already have the replications. So you can use this. And secondly, the throughput also increases. Okay. So this the leader one we can use only for writes, and for the reads other clients can directly use the secondary databases. Okay, so these are the benefits, and obviously single leader replication is very easy to implement. Now let's discuss some of the limitations of single leader replication. Okay, like not limitations, basically what are the problems which we can face if we use a single leader replication. So first problem, so let's say in this we have a data, okay, which is from like 0 to 100. Okay, and recently you have added few more datas, okay, which is like 101 and 102. Okay, so this got replicated to here. Okay, this got replicated to here till 100. Okay, after that this server crashed. Okay, so we know that we have replicated till 100. So when it comes up, okay, how will it know that which all data it has not replicated? Like 101 and 102 it has not replicated. How will it know? So this is the problem which occurs if the worker nodes or the slave nodes goes down. But this problem is pretty much easy. Just like whatever the future data which came, maybe you can use timestamp, but obviously timestamp are not reliable. Uh, yeah, so you can use some versioning number, and by that you can know like how much you have not replicated, and you can replicate it back. Okay, but the real problem comes when the leader goes down. So what are all the scenarios which happen if the leader goes down? So first problem is, okay, so let's say leader actually didn't went down. The router which is connecting the secondary, there is a router obviously which is connecting the secondaries with primary. Okay, so due to some reason what happens that this router went down. Okay, now this guy doesn't know that if the leader is there or not, so he tries to become the leader. How can we prevent it? Maybe there can be some communication between them. Okay, so these are actually not the real solution. We will discuss the real solution in the future videos, and these are just context setting. This is just a context setting video. Okay, so he asked, hey, is the leader down? He says that no, leader is not down, your network is down. Okay, so he waits until the leader comes back. Okay, and when the leader comes back, he replicates rest of the data. Okay, this is the first problem. Now the second problem is, so this guy was the leader. Okay, this is the like leader, this is the like this is master, this is slave. Okay, so what happens that in this database there is data 100, there is data 180, and a new data came, okay, which is 120. But as soon as the new data came, leader crashed. So in the secondary, actually what happened, there was like 100 data was replicated, 180 data was replicated, but 200 data was not replicated. So as soon as it goes down, uh, this guy doesn't have actually the 200 data. Okay, but someone has have to serve the traffic, right? So due to which what happened, this 180 to 200, this data got lost, and this may be possible that 180 to 200 data was extremely important, but you lost it forever. Okay, this was the second problem. Third problem is actually a continuation of the second problem. Okay, so like I said, there were like 100, 150 and 200, there's three data in the primary, and in the secondary there was 100 and 150. Then something happened due to which primary went down. Okay, then this secondary becomes the leader. Okay, so now, so previously it was leader 1, now it is leader 2. Okay, then let's say after 1 or 2 hours it comes back. Okay, now he doesn't know that what to do with his data. So he had data till 200, right? But this guy had 150. After that, let's say some other data came, so 150 to 200 got lost, and from 200 to like 300 this data came new. Okay, but when he comes back, he says that, hey, I had some 200, like 150 to 200 data previously, but I don't know what to do with it. So should I be leader? And he says, nope, you cannot be leader because I have new data. So like now syncing becomes like extremely difficult thing, like what to do with this 150 to 200 data. That can become a conflict also. Correct. So these are the three problems which may occur with single leader replication. Obviously, all of this problem can be solved if the replication is not asynchronous, it is synchronous. But synchronous, in this whole lecture we will more concentrate on asynchronous. We won't concentrate on synchronous because it's extremely slow. Okay, now let's jump to the what is multi-leader replication. So in multi-leader replication, what happens that there will be multiple leaders. Okay, so client can actually directly write to leader 1, client can actually write directly to leader 2 or leader 3, and every leader have their own followers. Okay, now the problem. So first problem is like how will they replicate data amongst each other? Okay, so there are two basic techniques which have problems and one advanced technique which doesn't, which is actually good. Let's go through them. So first is circle topology. So in circle topology, what happens? So let's say this is leader 1, this is leader 2, this is leader 3. Okay, leader 1 replicates to leader 2, leader 2 replicates to leader 3, leader 3 replicates to leader 1. Okay, very easy. But what are the problems? The problem is, what if leader 2 goes down? Okay, then leader 1's replicated data. So what happens? Let's say leader 1 was having A and B data, leader 2 was having like C and D data, leader 3 was having like E and F data. Okay, now it was responsibility of leader 2 to replicate A and B plus C and D to leader 3. Okay, A, B plus C and D. But now leader 2 is down, so leader 3 cannot ever get the data of leader 1. Okay, so this is a problem. Second topology is star topology. So what happens in star topology is that all the leaders, so this is like leader 1, leader 2, leader 3, leader 4. Okay, so all of them sends their data to the center database. Okay, so leader 4, all of them sends their data to leader 4, and leader 4 basically replicates all the data to each other. What is the problem? What if this goes down? Whole thing is screwed up. Okay, now what is the better solution? So this is the advanced one. So this is the hybrid approach in which what happens that every node replicates to each other. Okay, so this node, so in this basically every node connects with each other and they send the data to each other. Okay, so now let's take an example. This is a problem statement. So let's say this guy have a data A. Okay, so he sends data A to L2, L2 sends data A to L4, or directly he can send data to A4. So from here we got A here, from here we got A here. Okay, again from L1 to L4 we got a here. Similarly, from L4 to L3, we got an A here, and L1 to L3, we got an A here. Okay. Now, here we can see that this guy received A 2 times. This guy also received A 2 times. What can we do? Like, should we save it 2 times, or like, what is the solution over here? So the first thing, like how this database can understand like I have received A 2 times is like with every single change we can provide a unique ID. Okay, so let's say A equals to 1. Okay, so when it sees that I received A, I already have 1. So this, like A equals to 1, B equals to 2, C equals to like 3. Then some changes happened, okay, which is A dash. It is equals to 4. Okay. So when it receives A, it sees the epoch. So this number is basically called epoch. Okay. So it sees the epoch. It sees that I already have 1. This A is coming with A epoch ID 1. So I already have this. So I won't resave it. Okay. But if A dash comes to it, okay, like some changes in A happened. So previously A was equals to 100. Now A is equals to, let's say, 150. It sees that A dash came and its epoch ID is 4. So I don't have 4, so I can save it. Okay, this was problem number 1. Second is like this A keeps bouncing around. Okay, so like once this guy received A, now he will again send that A to L1 also again. Okay, so this A keeps like bouncing around. Like, so how can we control like don't like once everyone has replicated, don't send A again and again. Okay, how can we do that? So basically we can keep a tracker like who all are the people who have received the like data A, and let's say here is like L1, L2, L3, L4, right? So only L1 had it, so we only mark L1. Then L2 got it, so we mark L2. Then L3 got it, we mark L3. Then L4 got it. Now we see that all 4 got it, then stop bouncing around the A. Okay, so this is second thing. Second problem is write conflict. Okay, so this is leader 1, this is leader 2. Okay, now what happened at the same time? Both of the people actually sent that A equals to, this guy sent A equals to 100, this guy sent A equals to 150. Okay, now when they sync, they find out that A equals to 100 and A equals to 150. So which data to keep? Okay, so the knife solution is basically whoever comes at the end will be the final data. So let's say this was pushed as at 1 hour, okay, and this was pushed at 1 hour 1 second. Okay, so this will become the final data. But again, like I said before, like the using the timestamp is actually not a very good idea. Why? Because let's say this guy is in US, this guy is in India. First of all, which timestamp to take? Even if we convert the Indian time to US time, the second problem is like in the data centers, the clock actually works using quad crystals. Okay, so according to the temperature, the crystals movement can change, and which can actually differ the time little bit here and there. Okay, so again, we actually don't know who is the who is the right who we actually don't know the right actually which was made last. Okay, so it can be that this write was made at 100, or like, yeah, this can be possible that this write was made at 100, but due to some problem in quad crystal, this write became 101. Okay, third thing is actually they can take data from GPS signal. Okay, but again the problem is like GPS signal is sending the time to each of them, and it can happen that the it got received time this got received was bit delayed, and time this got received was 1 second ahead of this time. So again, like due to network latency, uh, the time may differ. Okay, so how can we solve them? There are some advanced methods like CRDT and everything. So like I told, this video is just a context setting video. These are the problems. Now I can go ahead and explain like how to solve conflicts, or like how to remove all the problems that comes with the replications. Okay, thank you.